I thought I'd do a video to help us remember what we've done so far, or at least here in the second half of this chapter. So to practice section 4, this was our scale drawings. Again, this is a whole standard all by itself. And so this is the one that we're pretty much going to solve with proportions, okay? So I'm just going to do a few practice problems on this page. It should be fairly similar to the kinds of things that you will be doing on the assignment. Alrighty, so let's just start. Now the ones you'll do on the assignment won't have any measuring because it's hard to do on the computer. So, but 1 inch equals 20 feet, and that's our scale, and we can use that. So I'm going to do 1 inch to 20 feet, because that's going to be my first fraction in all of these. So what is the actual length of the Impressionism art room? So length is going to be this way. It's in inches, so I should probably use the inches side. Okay, and so that's 1 inch. So it's a little bit more than 1.5 inches. Yeah. So that's 1 3/4 of an inch. If we want to be super exact, that would be 1.5. Anyway, something like that. I'm going to go with 1 3/4 on that one. So 1 3/4, if we did that as a improper fraction, 1 3/4, 4, that's 7/4. 7/4, and we want to know how many feet. So if we do our real cross multiplying, 1 times x is x, and then we have to do 20 times 7/4. So remember, let's see, we can do some cross simplifying. 4 goes into 20 5 times. 5 times 7 is 35. So it's about 35 feet. Okay, now it's nicer when we just don't even have to do the measuring. And again, you won't even have to do the measuring. So if we do a couple of these, one of these pictures, one of these down here, let's do the alligator because that's just for funsies. So we've got 2 inches to 1.5 feet. So we can totally use this scale. And we've got decimals there as well. If you wanted to, you can, if the scale, especially if it involves fractions, I would multiply by whatever the denominator is to get rid of the denominator so we just don't even have to mess with fractions. In this case, we're doing okay. So first thing you should always do is put the scale into the first fraction. Okay, this gave us feet, so that means we're going to be putting that in the bottom. 13.5 feet. We want to know what it should be in the model. So this time you can see we are going to have, we're going to do our true cross multiplying. So 1.5 times x is 1.5x equals 2 times 13.5, which is 27. Okay, and then we divide both sides by the 1.5. X equals 18. So it should be 18 inches. That's still pretty big. Like if we're, 12 inches plus another 6, that's a pretty big model. You can't see, but it's a decent size, scale alligator. Cool. All right, and then let's do one of these. How about we do this one, geography here. Salem and Eugene, Oregon are 64 miles apart. If the distance on the map is 3.5 inches, find the scale of the map. So this time we're actually going backwards because we need to find the scale. So in real life, they're 64, probably put that on the bottom. Usually we put real life on the bottom. So 3 1/4, I'm going to change that to a improper fraction. So 3 times 4 is 12 plus 1 is 13/4 inches to 64 miles. And so we want to know for 1 inch, how many miles is it? Sure, we'll do that for now at least. Okay, so x times 13/4 equals 64. And then remember to get rid of fraction you multiply by the reciprocal. So 4/13, 4/13. And this is going to be an interesting number. 64 times 4 divided by 13. And 19.69 miles. Well, all right, there you go. So that's kind of going backwards, finding the... Oh, and then we are supposed to find the scale factor. I was like, we need to have a conversation about scale factor. Remember with scale factor, that's finding, you start with the scale, but we have to put them, we're going to write them as a fraction or a ratio, but they have to be in the same unit. Okay, so let's practice scale factor on these two. So we've got 1 inch to 8 feet. We need to change feet into inches. Since there are 12 inches in a foot, then we're going to do 8 times 12. And so that's 96. So it's 1 to 96. And you don't have to write the units because they end up, it's inches and inches. And when you have it in the top and bottom, you don't have to write it. Okay. 1 centimeter to 4 meters. Remember, I had the metric system. Well, those of you that were in class, I had the metric system up on the board. You can always just do a nice search on that if you don't remember, but there are 100 centimeters in 1 meter. So that means 4 meters is the same thing as 400 centimeters. So that's a 1 to 400 scale factor. Okay, so that's what's going on with that one. Next one, chapter 7, section 5. This was drawing 3D figures. This one isn't too intense, but they do want you to draw top view, side view, and front view. So I'm going to do number 3 first because it looks like fun to me. Top view, if you're looking at it from above, you're going to have the big circle that's the base, and then the top circle, yay, it's a donut. Okay, front view, trapezoid, and a side view, I think is also going to be a trapezoid, right? Because, and you can see the drawings don't have to be super accurate because I can't do any better than that. So there you go. Top view on this one is going to be the shape of the base, which is just a rectangle. Okay, and the side is a triangle. And then the front is going to be that back rectangle. So top, side, and front. Okay, so again, I'm not holding these to any art standards. Just kind of get the basic point across. Okay, then you have to be able to go from one of those things and try to draw the shape from a diagonal point of view. This one's a little bit more tricky. So if we look at something, I actually like to start with the front view. I have no idea if I'm going to be able to pull this off, guys, so, you know, be nice. So start with the front view. And the top, holy moly, I have no idea how to see this. La, la, la. So I think there's one that's poking out right there. And the side. I think this top thing is this one right here. I don't know how to draw that though. So, you know, give it your best shot. This one should be a lot easier. We've got if we look at it from the top, it's going to be that. So I think it's this, and then the side is a triangle, and then the top is a triangle. So I think it's a pyramid, a rectangular based pyramid. I could draw it better than that. Maybe I can't. I don't know. Rectangular based pyramid. There we go. That feels better. And, you know, maybe I'll post a picture of what that one's supposed to look like. You know, drawing. It's fine. All right. And then the last section that we're doing today is section 6. And so the first part is identifying each figure and then do the bases, faces, edges, and vertices. So make sure you label all of those things. I'm going to go ahead and start with this one. This is a rectangular. So the figure is a rectangular based pyramid, right? Because they all come to a point at the bottom. It's an upside down pyramid, but that's okay. We can handle upside downness, okay? The base is the rectangle MNOP, right? You could name it something else, but like I said, normally we like to keep them in as alphabetical order as we can. Okay, then the faces, the base is a face, so MNOP, and then the rest of them are going to be triangles. So triangle, the front one is OQP, and then this side one would be NQO, and then triangle, this one in the back would be MQN, and then this side one, PQM. Okay, so those are all the faces. And then the edges, remember those are the lines. That's where two faces meet. And those are line segments, so if possible, write them in line segment form. So let's go around the base first. We've got M to N. We've got N to O. We've got O to P and P to M. Okay, that's those edges. Now we'll do the 4, and they will be each of those letters with a Q. So OQ, line segment NQ, line segment MQ, and line segment PQ. All right, and then the last thing is the vertices. And this is the easiest. You'll literally just have to write those letters. So we have M, N, O, P, and Q. All right, so it's a lot of writing, but hopefully it's not too tricky. Okay, and then the rest of this one, and again, this is a standard by itself as well, being able to describe cross sections. Okay, so this is a rectangular prism, and we're going to slice it horizontally, which means the cross sections can be the same shape as the base, and the base is a rectangle. Okay, so rectangle right there. A vertical cross section of a cylinder, this is a cylinder, and that actually turns also into a rectangle. Okay, this one, when you've got a cone and you cut it on the diagonal, if it was straight across, if it was straight parallel, it would be a circle. But because it's a bit diagonal, that's actually going to be an oval. If you want to be fancy mathematical, we call that an ellipse. I probably spelled that wrong. So just go with oval. All right. And then over here, we've got a rectangular prism, but it's being cut diagonally. It still makes a rectangle though. All right. And cross sections. That was it. Super exciting. And yeah, let me know if you have any questions.